I'm tired of testing my code only for it to break production a few hours later.
I mean, come on, I put so much effort into crafting the perfect feature. My tests go green and I ship my code, but it crashes in a way that never showed up locally. And now the users don't get that sweet feature out of it. My tech lead tells me off, and I cry in the corner, screaming into the void. But I added integration tests.
This is what happens when you're not testing against real infrastructure.
And that's because you're probably using mock databases with fake responses and you struggle to replicate an actual request. They only tell you what you expect to hear and can cause you massive issues in production. This is where test containers come in. It spins up real Docker containers, actual Postgres to run part of your test suite.
And in this video, I'm going to show you exactly how it works and how to set it up in a real project so you can avoid the same fate as me. But before we get into the project, let's talk about what test containers are and why they're becoming so popular.
Well, usually when you're writing integration tests, you are writing integration tests, right? Okay, well when you do write integration tests and you want to call a database, you kind of have two choices. Either you spin up a version of the database in some test environment, setting it all up with username and passwords, maybe adding some fake data in. Then you completely forget to turn it off and watch all your money burn in some AWS warehouse somewhere.
Which is all kind of a pain to manage. The other option is to create a mock client.
And mocks are basically just functions that mimic how the database would normally respond.
This way you can make fake calls out to your database without actually affecting anything. You always get the response that you want, you don't get a lot of the flakiness that comes with interacting with a live service, and you don't get tests conflicting with one another. But the problem is you miss out on some of the complexities that you get with interacting with a real service.
A real Postgres enforces real constraints. Real Redis has TTL behavior.
Your mock doesn't have any of that. So as useful as they are, you can't really claim that you're testing against real infrastructure if you're just using a mock.
Test containers fix this by replacing your mocks with real containers, real versions of the infrastructure you're already using. It pulls the Docker image, starts the container, and hands you a real connection string. And it even tears everything down for you once the tests are complete.
So you get all the benefits of testing against real infrastructure without any of the pain of managing it all. So let's test this out and let's implement it on a real project.
We can start off by going to the TestContainers website. Here we can see all of the platforms supported, and we can also see an example of the sort of things you might want to build with. Now we could follow this tutorial, but we also have something called modules, which is what we're going to be using today. They're easier to use, and to be honest, I know you're all lazy devs anyway. No, I'm kidding. Modules are just a really easy and helpful way to get started with your tests. And I've got a project for this video, a URL shortener. I know, really breaking out the big bucks here. But the gist of it is you send it a URL, it shortens it down and creates a redirect for you, and then provides some statistics on how many times it's been clicked, and yeah, you get the idea. The most important thing you need to know is in this project, we're using Postgres for the data storage and Redis for the caching and rate limiting. And then for the code, we're writing that in Golang. Why are you using Go, you might ask? Well, because I like it, that's why. I like their little mascot here. He comforts me. But if this friendly little guy isn't enough to move your entire codebase to Go, well, on the website you can see that Test Containers supports lots of different languages. We can click into the Golang one and see some documentation about setting it up. Alright, so scratch that. We're doing modules today. So let's navigate to the modules section, start off by clicking Go, and then relational database, and we can see Postgres right there. And let's start by getting the Go dependency set up. Once that's installed, I'm just going to wire up the Postgres container. We can declare an image, the exposed port, and our username and passwords. That's all you need to do. And for comparison's sake, if we weren't using modules, look how much stuff we'd have to set up. Haha, suckers, all aboard the Module Express. Okay, so we've got our Postgres test module set up. Now we don't actually need to worry about downloading Postgres itself and having our own running version. Test containers will handle all of that for us. All we need to make sure is that we supply an image tag. That of course will be the same image and version that you're using in your production infrastructure. Don't you go setting up all these test containers and then accidentally using the wrong version. Or the gopher will be coming for you. Now that we've got all that set up, we can write tests like we normally would. So in our project here, we have this store that allows us to create our URLs and get them from within Postgres. So let's write some tests, baby! We can actually just call the functions directly from within our test container store. So let's create one for creating new URLs, and one for getting existing ones. And then we can run the test as usual, just running go test. Go will grab the Postgres containers that we've specified and wait until they're ready for use. Then make real requests to the database with the SQL that we use in our application in production. No mocking of any data, real requests being tested in a safe, repeatable manner. And as you can see, all of our tests are passing, and if we look at the running Docker containers, yep, that's right, you'll see it's empty. Test containers has already gone in and removed all the remaining containers used as part of this testing suite. How cool is that? It's so helpful not leaving loads of dangling resources hanging around. But wait, what if we already have containers running on this machine? What if we are already running Postgres? Oh my god, are our tests going to clash and start trying to push data to the wrong instance?
Is it going to clean up all of our other containers? Well, no. If you already have containers running on the same port, TestContainers will automatically report the image it creates to something that's available, and it'll spin up and spin down those containers without you even really noticing.
If you're enjoying this video so far, please do consider liking and subscribing. This is a very small channel, and you probably won't see my videos again if you don't click some of those buttons. Anyway, let's get back to testing.
Okay, as part of our URL shortener app, I've also got a Redis component that handles all of the rate limiting. The rate limiter is simple enough, it blocks people if they're sending too many requests in quick succession. And to test that, I've got a mock version of Redis, no test containers. My test sets a user's rate limit at 5 requests. Then I'll send 10 requests. And we should see that the test implementation works as expected. My 5 first requests go through, and then the following 5 get blocked. Exactly what we wanted. Then we ship this feature to production, and it doesn't work?
It's not true. That's impossible!
We try it in our production instance, but every single request goes through successfully. No blocked rate limits. Wait, why is this happening? Well, our mock was incrementing an in-memory counter, but it had no TTL. In reality, Redis keys expire after a window. The mock never did. So in the test, the counter kept climbing and blocking correctly. But in prod, the key expires, the counter resets, and every request gets through. And this is why it's so important to test against the real thing. So let's solve this the same way we did with Postgres. Let's find our Redis module, pull in the dependency, and wire it up in our code. Now we can run our test suite with the test containers instead of our mock. And we can see the rate limiter bug caught properly in the test, not by a real user in live production.
This is fantastic. I love test containers. They're lightweight, they're easy to install, easy to use, and they give me so much security that I'm testing against real infrastructure. So if you're working on a project like this, then I definitely recommend trying it out. And if you want to find out some of the biggest security issues that are hitting vibe-coded apps in 2026, click this video here.